Hello, good morning or good afternoon to everyone. This is Deepak Raj Chhetri from Penciling Middle Secondary School. Welcome to my 6th video lesson on Physics, Chapter 3. Today we are going to learn about potential energy and kinetic energy. We need energy to perform any kind of works. So without energy, we cannot walk, we cannot do any activities that we are doing daily. And energy is defined as a capacity to do work or capacity of a body to do work. Among different forms of energies like light energy, chemical energy, sound energy, heat energy, mechanical energy, electrical energy, etc. Today we are going to discuss about mechanical energy. So energy possessed by a body due to its position or height is called potential energy, and energy possessed by a moving body is called kinetic energy. So when you add up these two energy together, we call it as mechanical energy. Sum of kinetic and potential energy is called mechanical energy. So now we are going to look at more detail. Any object that is kept at certain height or raised to height against the gravity possesses potential energy. Example, rock at the top of the hill and water at the high altitude has potential energy due to its height. And some other objects like a spring, which is wound, which we find inside our ball pen and in spring balance, or stretched rubber band has potential energy due to its state. So potential energy is measured by the amount of work done in taking the body to that state. Suppose we are talking about the potential energy of a stone on top of a cliff. So potential energy of a stone on top of the cliff will be equal to amount of work done in taking that stone to that top of the hill. So the amount of the energy stored in the rock and amount of energy used in taking that stone, carrying that stone to the top of the hill will be equal. And other example is rubber band. If you look at the rubber band, the amount of energy stored in the rubber band will be equal to the amount of work done in stretching the rubber band. The more energy you apply in stretching the rubber band, greater will be the energy stored in the rubber band in the form of potential energy. If a body has mass m and is raised to a certain height h against the force of gravity, then work done is force times displacement. So when we replace force by mg, since we are carrying certain mass against the gravity and the value of gravity is 9.8 meter per second, so F is replaced by mg. After replacing F, we get work done as mgh. And the potential energy is equal to work done in raising the body to a certain height. Therefore, we use potential energy as mgh. So in this formula, m is mass, g is acceleration due to gravity, and h is the height to which it is increased. So from here we can also conclude that potential energy depends on mass, height, and value of acceleration due to gravity. If the mass is bigger, if the body which is on the top of the cliff or at certain height is bigger, if it has more mass, then it will have more potential energy. And if you go to a planet where the acceleration due to gravity is more, there also we will have greater potential energy. And the height, of course, if the body is raised to certain height, then it will have some amount of energy. If we increase the height, potential energy also will increase. Now let us look at one example. A fully loaded elevator has a total mass of 1950 kg. If it is raised to 24th floor, a distance of 96 meter in 15 seconds, calculate the potential energy of the elevator. And they have given acceleration due to gravity as 9.8. Now we are given mass, acceleration due to gravity, and height. And time is also given, but which is not required now unless we are asked to calculate the power. Now potential energy is given as mgh. So when you substitute the values, mass is 1950, g is 9.8 times 96 meter height. So when you calculate, we get 183456 0 joule. So that is the potential energy of the elevator that is loaded, and then it is kept at 96 meter high. The elevator will have potential energy, so that is same thing. So this question was given last time for you to try. So if some of you have not tried, you can do it now, and if you have not done, you can if you have already done, you can just cross check the answer. A mass of 5 kg is raised to a certain height of 2.5 meter above the ground. Calculate its potential energy, and the value of acceleration due to gravity is 9.8 meter per second square. Potential energy is mgh, so that we have seen just before the slide. Substituting the value, mass is 5 kg, value of acceleration due to gravity is 9.8 times 2.5. We get potential energy is equal to 122.5 joules. And the next question was also given to you as a practice last time. You can cross check it. Here you are asked to calculate mass instead of potential energy. A huge rock is placed on top of 12 meter high cliff and has a potential energy of 3 times 10 raised to 7 joule. Calculate mass of the rock, and the value of acceleration due to gravity is also given. We will use the same formula, but we have to convert since we are going to calculate mass. When you separate the mass and make it a subject of formula, we get mass is equal to PE over GH. So in this case, this M is the subject of formula which we are keeping here, and then this GH we are moving to other side. So when you move GH, it goes to denominator, and we are just reversing. M we are writing this side. So when you write PM is equal to P over GH, so we get this. Then next, M is equal to value of potential energy and divided by G times H. So H is 12 meter and G is 10 meter per second square. So when you calculate these two, we get 120, 3 times 10 to 7 divided by 120, and the mass of 250,000 kg. Now let's go for kinetic energy. A body in motion can apply force on another body and bring about displacement. For example, when a moving ball hits another ball at rest, it can make the ball at rest move. This means a moving body possesses certain kinetic energy. The energy possessed by a body due to its motion is called kinetic energy, and it is measured by amount of work done in bringing the body into rest, or bringing the moving body into rest. If you look at the ball here, a ball is at rest. So when another ball comes and hits the ball at rest goes into motion. Now let us see how to derive relation for kinetic energy. If the body has mass m and is moving with a velocity of u and is brought to rest, the final velocity will be v. Final velocity will be 0. So whenever body moves, when the body moves from the initial point or rest, we will have initial velocity 0, and when the moving body comes to rest, obviously the final velocity will be 0. Using the Newton's equation of motion that we have seen in class 9, v square minus u square is equal to 2as, or the equation you have in class 9 is v square is equal to u square minus 2as, and that when you bring it when u is brought towards left hand side, so this u, when you bring this side, it becomes v square minus u square is equal to 2as. So now here v is the final velocity, u is initial velocity, and a is acceleration due to gravity, s is the displacement. Now since we have already discussed a condition when the body comes to rest, moving body comes to rest, final velocity will be 0. So 0 square will be 0, and u square will be equal to minus 2as. So here 2as has a negative sign, so that shows that the body is coming to rest and has a decreasing acceleration, as the body comes into rest, acceleration of the body will keep on decreasing because velocity keeps on decreasing. We will have negative acceleration, and negative acceleration is also called retardation. So retardation is when the velocity of body decreases with time. The condition is called retardation. And here when we separate s, because we are focusing on calculating what is the value of s, so now when you separate s, the 2a goes to other side and the sign negative sign gets cancelled, and we are left with s is equal to u square over 2a. So when we cancel this sign, negative signs, s will become u square over 2a. Now work done in opposing the motion of a body is force times displacement. We have seen in the previous lesson that work done is equal to force times displacement, or W is equal to Fd cos theta. We have seen that. And if the body moves in the direction of the force applied, we can consider only force times displacement. Now using this concept, work done is F times d. Now if we use this F times d, F is equal to ma, and displacement we have already derived here. If you substitute this value of displacement, if you substitute by u square over 2a, ma is f, this ma is f, and the u square over 2a is this one, d. So when you put together, a and a get cancelled. If you put together, we have m over ma u square over 2a, and this a get cancelled. So when we cancel a, we have mu square over 2. Finally we get kinetic energy is mu square over 2a, and since u is also velocity and kinetic energy is amount of work done in opposing the body motion of the body, we have got mass times velocity square divided by 2. So finally we write kinetic energy as K is equal to mv square. Now let's look at some example of kinetic energy. A car of mass 400 kg gained kinetic energy of 80,000 joule. Find its velocity. We are given mass and kinetic energy. We are asked to calculate velocity. So we know kinetic energy is mv square over 2, and rearranging the equation we get velocity square. Velocity square is equal to kinetic energy over m, and when you substitute the values we get 2 is the number that is already there, 80,000 is the kinetic energy divided by mass 400, so we get 400, and the velocity we get v is equal to root of 400. Now here v square is 400, so which is not the velocity, it is square of velocity is 400. Taking roots on both the sides, we have got root of v square is equal to root 400. Root of v square is v, and this side we have got root of 400 is 20, and velocity we got as 20 meter per second. So velocity of the car is 20 meter per second. And the next question is, bullet moving with the velocity of 30 meter per second has a mass of 200 gram. Find its kinetic energy. Now this was also given to you last time as a practice question, and the hint is given there. Kinetic energy is half mv square, and we have got 200 gram. Now here one unit is given as a meter per second, SI unit, other unit is given, other quantity is given as smaller unit, CGS unit. We cannot calculate these two because velocity is given in bigger unit, whereas mass is given in the smaller unit. First we have to convert the gram into kg, then only we can implement in the formula or substitute in the formula. So when you calculate kinetic energy, half mv square, so upon substituting we get half times mass is 0.2, v square is 30 square. So we get half times 0.2 times 900, 30 square is 900, half of 180 is 90 joule. Next question here, A toy car moving with a velocity of 25 meters per second has kinetic energy of 4000 joules. Find its mass. Alright, these things are clear, I think. Kinetic energy is half mv square, and just to make it easy, to make our steps easier, I have just written this one first. Now if you write this first, we are just bringing the m, which is our subject of the formula. So question has asked us to find the mass. To make it easy, we are writing this missing part in the left hand side. Now to separate, this 2 will go and multiply with the kinetic energy. V square will come and divide. It will go to denominator when we cross this equal to sign. Now we have got m is equal to 2 ke divided by v square. So now when you substitute the values, m is equal to 2 times 4000 divided by 25 square. So 2 times 4000 will be 8000 divided by 625. We get the mass of 12.8 kg. So that the toy car has a mass of 12.8 kg. Alright, thank you all. Stay home, stay safe, and take care of yourself, and keep learning. So you can come for next video that I'll be posting very soon about the next topic. So thank you.